Let us have a look at our next method. As someone mentioned yesterday, what's the point of doing this when we come up with the same idea that we used in 2-unit anyway? We're just wasting time. And of course the answer to that is we never waste time in maths. All right, now, okay. But there is an alternative way of doing it. So this time, instead of slicing perpendicular, we're going to slice parallel to the axis of rotation. So here's our function, our random function. So again, it's the same area, but I'm rotating around the y-axis instead of the x-axis this time. Now, when I rotate around the y-axis with the parallel rotation, if I rotate, I'm no longer going to get a disc. What we end up with is like a cylindrical shell instead. What I tend to do with the cylinder, however, is to unwrap it. And if you unwrap that cylindrical shell, you get a rectangular prism. You might be thinking, oh, hang on, it's not a rectangular prism because there's a thickness there. Surely the outside is going to be smaller than the inside or vice versa. But remember, we're talking about delta x is approaching 0. So they're so close to being the same anyway, it doesn't matter. So the thickness of my rectangular prism is delta x. So I want everything in terms of x this time. The height would be the y value, so whatever the function is. And the width of it would end up being the circumference of the shape. Now the radius of this cylinder is the x value, so the circumference would be 2 pi x. And so that gives us an area of the face of our slice there of 2 pi x times whatever function x is. And then delta v is 2 pi x function x delta x, and we can carry on like normal and go, okay, well that's the limit, and so on. Now, some people substrate into 2 pi xy. Don't do it. As you might have noticed yesterday when I put the syllabus up there, it specifically says, do not do that, right? Because they're not interested, can you substitute into 2 pi xy? They want you to build the shape like we were building it yesterday. So let's do the same question as yesterday, but now we'll do it with cylindrical shell. So it's 4 minus x squared, and we're going to rotate it around the x-axis. So there's our upside down parabola. But we're going parallel. My slice is parallel this time. So if I rotate that around the x-axis, there's my cylinder. Unwrap it, I get the rectangular prism. Thickness is delta y. The width, the way I've got it here, would actually be twice the x value because we've got the symmetry there. Twice the x value. So we'll end up with twice, got to make x a subject. X would end up being the square root of 4 minus y. So we've got twice the square root of 4 minus y. Oh, square, and the length would be the circumference, and that's going to be 2 pi y. 2 pi y. All right, so the area of our face there, 2 pi y times 2 lots of the square root of 4 minus y. Delta v then would be 4 pi y, square root of 4 minus y, delta y. And be careful here, you're not going from minus 2 to 2. Remember, we're slicing up now. So it's the y values we're using. We're going from 0 to 4. And there is no symmetry from 0 to 4. So don't go 2 times or anything like that. All right, we have to integrate y, 4 minus y to the power of a half. Oh, that's annoying. I'm going to change that using, remember the idea we saw at the end of the integration topic? I'm going to replace y with 4 minus y. And that gives me something easier to integrate. And add 1 to the power over the power. And there is our volume. Amazingly, same answer as yesterday. Thank goodness for that. Find the volume when x squared plus y squared equals 4, rotated about the line x equals 4. We're going to end up with, there's our circle. We're going to rotate it around x equals 4. What shape do we get? Thank you. Donut, mathematical name, torus. Well, I'm going to slice parallel to the axis, so I've done a vertical slice there. And when I rotate it round, we'll get a cylinder. Now, here's my attempt at drawing a torus. There you go. Look, see, donut. Ooh. Torus. That's how you spell it. It's not A-U-R-S. We got our slice. thickness in terms of x. So we've got to be careful here. We're not rotating around the y-axis. It's x equals 4. So let's sort out the height first. That's the easy bit. It's going to be twice the y value because of symmetry there. I need it in terms of x though. So it'll be the square root of 4 minus x squared. Now, circumference is 2 pi the radius. The radius is not the x value. The radius is 4 minus the x value because we're starting at 4 and we're going back to our shape. So 4 minus whatever the x value is. Okay, so area x, 2 root 4 minus x squared, 2 pi 4 minus x. Tidied that up a little bit there. Delta V, 4 pi 4 minus x, square root of 4 minus x squared. So we're going to sum from minus 2 to 2. So that will be the 4 pi, the integral, minus 2 to 2, 4 minus x squared of 4 minus x squared. Watch and be amazed. I'm not going to do any integration. I'm going to split that up into two things. The first one is 4 times the square root of 4 minus x squared. Integrate the square root of 4 minus x squared from minus 2 to 2. Semicircle. Have a look at the other one. X times the square root of 4 minus x squared. Odd function. Very good. Did you cheat or did you? Okay. So the first one tidies up to be 16 pi. There's our semicircle. So pi r squared, but semicircle half pi r squared. The other one, odd function times an even function. So we know that integral is 0. So we got 32 pi squared units cubed.
I don't get why the radius is 4 like that.